Hello dear students, welcome to another session. In this session we will discuss about the combination of pulleys. This is in continuation of previous session where we studied about the single fixed pulley and single movable pulley. And we saw that in single fixed pulley the mechanical advantage was 1, which means there was no force multiplier, there was no gain in speed, only we were changing the point of application where we were applying the force. And in single movable pulley the mechanical advantage was 2, hence we can say that we were using it as force multiplier. But to uplift very heavy load, the mechanical advantage 2 is not sufficient. Hence, we are going to use the multiple number of pulleys, movable pulleys, to uplift any heavy load. So, in this session, we will discuss about the combination of pulleys. The combination of pulleys can be done in 2 ways. In the first one, we will fix one pulley and other pulleys where will be movable. And the other system to make a combination of pulleys is block and tackle system. So we will discuss about these 2 systems and we'll see that what is the mechanical advantage, velocity ratio and efficiency with the help of these combination of systems. So let's start today's session. So first of all, we will study the combination where one pulley is fixed and other are movable pulleys. Okay, these pulleys we are using to lift heavy loads. Okay, so this is the first system where one pulley is fixed, this one is fixed, while the other pulleys are movable. These 3 pulleys are movable. Okay. Suppose that we are hanging some load L at pulley A. With the pulley A. With pulley A, a load is hanged. Okay. And effort we are applying at this end is equal to T3. Effort is equal to T3. T is tension. Tension in this string or rope, right? T is tension in this string. As here we are taking tension T1, here T2, and here the tension is T3. So T3 is tension here. Okay. So E is equal to T3. What will be the value of load L is equal to? How many forces are working against this load? T1 and T1. So 2T1. Right? Load is equal to 2T1. Okay. What will be the value of this T1? T1, as you can see here, T1 is equal to 2T2. Okay, T1 is equal to 2T2 and T2 is equal to 2T3. T1 is equal to 2T2. See, here the T1 is equal to 2T2 and T2 is equal to 2T3. Right? T2 is equal to 2T3 and E is equal to T3. Okay. We will put the value of T2 in this. Then what will be the value of T2? Then what will be the value of T3? Okay, so we will put the value of T1 from here. So what will be the value of load L is equal to 2 and T1 is equal to 2T2. 2T2. So it will be equal to 2 square T2. Okay. So load is equal to 2 square T2. Now what is the value of T2? we will put here the L is equal to 2 square into, in place of T2 we will write 2T3. Okay, so it will be equal to 2 to the power 3 T3. Okay, so this is the value of load. Once again I am repeating, as you can see here, effort which we are applying, against the effort only one force is working, and that is tension in this rope, which is equal to T3 in this D pulley D. Okay, and at this end, at pulley A, we are hanging some load. How many forces are working against this load? T1 at this side, the side which is fixed with the rigid support, and T1 at this side, at which side the pulley B is connected. Okay, so total support, so the total forces which are acting against this load are 2T1. So L is equal to 2T1. Okay, this is the first. Effort is equal to T3 and L1 is equal to 2T1. Now, how many forces are working against this T1? Two forces, and those are T2 and T2. T2 at this side, which side the rope is fixed with rigid support, and another side the pulley C is connected. So T1 is equal to 2T2. Similarly, the T2 is equal to 2T3. We'll put the value of T1 first, then T2, and then the value of T3. Okay, so we will get load is equal to 2 to the power 3 T3. Now what will be the mechanical advantage? It is equal to load upon effort. So load is equal to 2 to the power 3 T3 and effort is equal to T3. From here, effort is equal to T3. So this T3, T3 will be cancelled out. Hence, what will be the value of mechanical advantage? It will be equal to 2 to the power 3. Okay, 2 to the power 3. This will be the mechanical advantage. Now we will calculate the velocity ratio. What will be the velocity ratio? Okay, let's see the value of velocity ratio. Velocity ratio is equal to effort arm upon load arm. Okay, so first of all we will discuss what will be the effort arm. How much displacement will be there in effort arm? So effort arm okay, as you can see here that one segment of this movable pulley is fixed. Hence, the total displacement at this segment will be double. As you can see here, the one segment of this pulley is fixed. Hence, total displacement at this segment will be double. So, x by 2 was there. Hence, it will be x displacement at this side. Now, on the pulley B, the displacement will be x here and x here. It should be, but since this is fixed, so here the displacement will be 2x. Again, at this pulley, the displacement will be now at this pulley x, 2x, 2 to the power 2x, right? Since here will be 2x and 2x, so the total will be 2 to the power 2x, and the total displacement will be 2 to the power 3x here. So the effort arm will be 2 to the power 3x. How much displacement will be there in load arm? How much displacement will be in load arm? It will be equal to x. X by 2 at this side and x by 2 at this side. So this is fixed. hence total will be at this side only, total displacement will be at this side only, so it is x. So load arm is equal to x. So velocity ratio is equal to effort arm upon load arm 2 to the power 3x upon x. So it will be cancel out, hence what we will get, 2 to the power 3, right? This is what the velocity ratio, 2 to the power 3. Mechanical advantage is 2 to the power 3. Velocity ratio is 2 to the power 3. Okay. So efficiency, what will be the efficiency? Mechanical advantage upon velocity ratio. So it will be 2 to the power 3 upon 2 to the power 3 means 1, or we can say 100% efficiency. In ideal case, while in practical case or actual practice, both weight of the pulleys and string and pulleys weight and friction between the bearings of the pulleys reduce the mechanical advantage. As we have already told you that these are the causes, the weight of the pulley and the string, both weight, string's weight and pulley's weight. Along with this, the friction between bearings of the pulleys. These will increase the amount of effort which we have to apply. Hence, mechanical advantage will reduce. If the mechanical advantage will reduce, then efficiency will definitely reduce, because efficiency is directly proportional to mechanical advantage. Right? So in actual practice, efficiency is not 100%. It is less than 100%, 90% or 80%. Right? Suppose that efficiency is 80%. Suppose efficiency is 80%. Or 80 upon 100 means 0.8. Then in this case, what will be the mechanical advantage? So the mechanical advantage is equal to efficiency multiplied by velocity ratio. Right? So velocity ratio is fixed. Velocity ratio will be fixed. The number of pulleys we are using will be equal to velocity ratio. So with the help of this formula, we can calculate mechanical advantage. Okay. If velocity ratio is fixed, as I said, it will be fixed. Efficiency is given to you and you have to calculate the mechanical advantage, then you can calculate with the help of this formula. Okay. Moving on next. Now we'll discuss about block and tackle system. So this upper portion is known as block. So this upper portion, so this upper portion is known as block and this lower portion is known as tackle. Or in some of the books, it is written that these rope which we are using here, this rope is tackle and these fixed pulleys are block. These pulleys are block and rope is tackle, because this rope is tackling this block. Okay, so that is why it is known as block and tackle system. In some book, it is known as block, upper portion is known as block and lower portion is known as tackle. Okay. So this is an arrangement known as block and tackle system. What you have to consider here, that upper portion, the number of pulleys in upper portion should be always greater than or equal to number of pulleys in lower portion. right? This you have to consider while making the combination of pulleys in a block and tackle system. Okay. So now we will calculate the mechanical advantage. First of all, we will calculate the mechanical advantage. There can be different type of combination, as we are using the 3 pulleys in upper part and 2 pulleys in lower part. It can be 2 pulleys upper part, 2 pulleys lower part. It can be 4 pulleys in upper part and 3 pulleys in lower part. So that doesn't matter. If you will know the concept, you can calculate for any of the block and tackle system, for any of the combination of lock and tackle system. Okay. So as you can see here, how this rope is connected. Let's see. I will try to make it. This is the rigid support. Okay. And 3 pulleys are connected in upper part. 1, 2, 3. This is the first pulley. This is the second pulley. This is the third pulley. Okay. And at lower part, there are 2 pulleys. First, second. This is the first pulley. This is the second pulley. Okay. And here, there is a, okay. Now, hook. It is hook. Right. Now, a rope is used and one part of rope is here where we will apply effort, and other part of the rope is here. It will go down, and with this now it will come again here. Now will move again here, then it will move again here, and then it will connected with this hook, the hook which is connected at lower parts pulley. So it will be connected with this only. So this is how we will connect the rope. Okay, got it? This is how we will connect the rope. Suppose that there is a combination of 2 and 2 pulleys at upper part and 2 pulleys at lower part. Okay, these are the 2 pulleys at upper part, and these are the 2 pulleys at lower part. Okay. This is the hook and this is hook. Now how we will connect? This is the effort point where we will apply effort, and another part of rope is here. Then we will move it here, then it will go here, then it will connected with this, with the hook of upper part of pulleys, right? With the hook of upper part of the pulleys, right? Opposite to the direction, in which direction it is coming. If it was coming in this direction, then at lower part, then at the hook of lower part pulleys, and if it is coming here, then with the hook of upper parts pulleys. Okay, since it is coming from downward direction, so it will go in with the upper part pulleys, and since here it was coming in downward direction, here it was coming in upward direction, so we connected it with the upper part pulleys hook, and here it is coming in downward direction, so we connect it with the lower part pulleys hook. Okay, hope now you will be able to connect the rope with these pulleys. So let's try to calculate the mechanical advantage with the combination of these pulleys. So first of all, what is load? So how many forces are working against this load? One tension must be here in this rope, here in this rope, here in this rope, here in this rope, here in this rope. So total 5 tension forces are working against this load. As you can see here, total 5 tension. Tension number 1, tension number 2, 3, 4 and 5. So total 5 tension force are working. Right? These. So load is equal to 5T. And in block and tackle system, effort will be T only in this. This is the effort and tension is working against this effort, so T. So what will be the mechanical advantage? It will be 5T upon T, means 5. So mechanical advantage is 5, much greater than 2. It will work as force multiplier. And now we are able to uplift the very heavy loads. Okay. Since mechanical advantage is 5, what will be the velocity ratio? The number of pulleys we are using here, it will be equal to M. Don't go in details, very simple. The number of pulleys you will use, the velocity ratio is fixed. It will be always equal to the number of pulleys you are using in block and tackle system. So here we are using total 5 pulleys, so velocity ratio will be 5 and it will be fixed for a particular combination. Okay. Now what will be the efficiency? Efficiency is equal to mechanical advantage upon velocity ratio. So it will be 5 upon 5 means 1 or 100%. So this will be again for ideal case. In actual, the efficiency will be lesser than 100%. Suppose that efficiency is 90%. Suppose that efficiency is 70% or 80%. In that case, what will be the mechanical advantage? Suppose in this system, if the efficiency is 80%, then what will be the value of mechanical advantage? So as we can say, efficiency is equal to 80%, or we can convert it into decimal value. 80 upon 100 means 0.8. Okay. So mechanical advantage is equal to efficiency multiplied by velocity ratio. Here 0.8 multiplied by number of pulleys are 5, so velocity ratio will be 5. So mechanical advantage is 4. Right? So mechanical advantage will be 4. And this will be the actual value of mechanical advantage. Because efficiency is reduced here and we calculated it 80%. If the efficiency is 80%, mechanical advantage will be 4. Right? In ideal case, it will be 100%, efficiency will be 100%, but then the mechanical advantage will be 5 as we have calculated. But in actual case, efficiency will reduce since more effort will be applied here. Why the efficiency is reduced? Because more effort will be applied at this side due to the friction of bearings at axle and due to the other resistive forces, due to the weight of this rope, due to the weight of pulleys, right? So the weight of these pulleys should be minimum. The pulleys we are using at lower part, since upper parts pulleys are fixed, so we will try to minimize the load of the pulleys which are hanged at lower part, right? So this is what efficiency of a block and tackle systems pulleys. Moving ahead. Okay, now let's see what will be the effect of weight of pulleys on MAVR and efficiency. Suppose that n number of pulleys we are using, right? Then in that case, what will be the value of effort? E is equal to T. Effort will be, it doesn't depend upon number of pulleys. Suppose that we are using 5 pulleys or we can use 7 pulleys, right? These are the lower part and these are the upper part. So effort will be equal to T only, na? Effort will be equal to T only. And what will be the value of load? L. Now we are adding the effect of weight, means we are adding weight of these ropes as well as these pulleys on this. So now L will be not L, it will be equal to L plus W, weight of the pulleys, right? And it will be equal to L plus W will be equal to number of pulleys we are using here, N into T, right? Here we are using 7, then N will be equal to 70. And if we are using N pulleys, then it will be equal to NT. Now, what will be the value of mechanical advantage? So before calculating that, we can calculate the load is equal to NT minus W. Okay, so mechanical advantage is equal to load upon effort. Load is equal to NT minus W upon effort is equal to T. So how much mechanical advantage we will get? N minus W upon T, right? So if here the value of N was 7, then mechanical advantage will not equal to 7. It will be less than 7, since W upon T will be subtracted from N. Hence we can see that mechanical advantage will decrease. Now what will be the velocity ratio? As we have already told you that the number of pulleys we are using will be equal to velocity ratio. So VR is equal to N. So what will be the efficiency? Mechanical advantage upon velocity ratio. Here the mechanical advantage is N minus W upon T upon velocity ratio is N. Okay, so it will be equal to 1 minus W upon NT. So efficiency will be 1 minus W upon NT. Means it is not 100%. Efficiency will be decreased. 1 minus means we are subtracting some value from 1. Hence efficiency will not equal to 100%. What does it means? If we are considering the weight of pulleys, then we will not get efficiency or mechanical advantage 1, the value of efficiency 100% and the value of mechanical advantage 1. We will not get it, right? And the value of mechanical advantage N, right? N means the number of pulleys we are using. Okay, so this was the effect of weight of the pulleys. Efficiency will reduce as well as mechanical advantage will reduce. Okay, hope you got it. So with this, now I would like to wind up the session. Before winding up the session, there is a beautiful quote for all of you. Stay positive, better days are on their way. Don't lose your hope. Victory and hope, there are two things which never dies. So never lose your hope. The better days will definitely come. Keep trying hard. Keep working hard. Okay. Stay positive. Positivity will be the reason why the better days will come. Okay. So with this thought, now I would like to wind up the session over here. We'll meet in the next session. Till then, take care of yourself. Have a great time. Thank you for watching this session.